In this video, we're going to learn how to graph tangent and the reciprocal trig functions. So up to this point, we've only dealt with sine and cosine and various types of graphing where we have verticals, shifting, we have stretching and shrinking. So now what we're going to do is we're going to look at just the basic parent functions for tangent and the reciprocals. So before we get into that, I just want to do a little reminder here of our unit circle. So I'm going to draw a set of axes, go ahead and get a unit circle on there as best as I can to make that look circular. And my key points here to remember, so this is 1, 0, 0, 1, -1, 0, and 0, -1. And remember that these points are going to give us the values for these angles in radians. So this would be 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and then back to 2 pi. So when we look at those 4 points, those tell us the cosine and the sine values. Remember that sine is equal to the y value of those coordinates versus cosine is equal to the x value. If I go ahead and look at individual triangles that create that bow tie, so if the radius here is 1, or the hypotenuse of this right triangle is 1, the x value is going to be x, or the cosine, the y value is going to be sine. So just kind of a refresher of stuff that we talked about in the previous unit. So we're going to kind of use this idea to come back and figure out, well, how do we graph tangent? How do we graph these other reciprocal functions? So if we think back to sine and cosine and how we use those to get tangent, well, tangent is equal to sine divided by cosine, or it's equal to the y value divided by the x value. So tangent, when we want to actually graph this, we're going to have to figure out our y and divide it by the x value. And then when we get into the reciprocals, well, the reciprocal of sine is going to be cosecant. So that means we're going to take and we're going to do 1 divided by y for all of those values. When we talk about cosine, the reciprocal of cosine is secant. So that means we'll do 1 divided by the x to get those y values. And then for tangent, well, the reciprocal is cotangent. So that's just going to be x divided by y. So that's how we'll figure out the values that we'll graph as our y values on our graph. So another important thing to consider here is the difference in the periods. So far we've talked about sine and cosine. So sine and cosine when we graph, oops, I did my theta instead of my O. So sine and cosine will follow the same period as cosecant and secant because those are the reciprocals of those, or I should say that cosecant and secant will have the same period as sine and cosine. So cosecant and secant, these will all have a period of 2 pi. Now, if there's a b value in front, then it would be 2 pi divided by b. But the most important thing here is to remember that the sine, cosine, and its reciprocals don't become cyclic, or the cycle doesn't repeat until we've had a length of 2 pi without a shift, with a b value of just 1. So then the difference here for the other functions, tangent and cotangent, these values will start to repeat after pi radians. So what that means for these, the period is going to be pi divided by b. So again, for the parent function, just the most basic function, it's just going to be pi. The values for tangent will start to repeat after pi. But if we have a b value other than 1, well, then that means you'd have to do pi divided by b. But like I said, we're going to be looking at just really the most basic versions of these. If anything, what you'll have to do is just find a calculate what the period would be. So as long as you know these formulas, you'll be able to do that. So when we go to graph tangent, so that's going to be our first one here, there's really 2 ways that we can draw a tangent, and that's important. to remember because it might not look the same always. So just so you know, there's two ways to draw a tangent. And one way is going to be with within its two vertical asymptotes, and another will mean where we kind of have a discontinuous function, meaning it's going to be split by a vertical asymptote. And notice I talked about vertical asymptotes, and the reason why there's going to be vertical asymptotes here is because now we're dealing with fractions. So if you look at tan and cotan, since we're dealing with fractions, we have a domain restriction. So if there's 0 in the bottom of our fractions, that means that we're going to have a vertical asymptote at that point. So what's going to happen is you're going to get values that are undefined, which means you have to have a vertical asymptote at that x value. So when we go to do this, let's go ahead and for this first method, I'm going to create my graph. So method number 1, when I draw this, I'm going to draw a tangent so that it's continuous. So I'm going to draw it as a continuous function, meaning I can draw it in one continuous motion without picking up my pen or pencil. So I'm going to draw it as a continuous function, which means that it's drawn between the two vertical asymptotes. So like I said, the period, since this is our most basic version of tangent, so this is like our parent function, there's no b-value, well, the b-value is 1. So that just means the period is going to be pi. So now when I go to do this, we're going to treat our labels the same way. We want to find the 4 key points here. So for my labels, I'm going to continue how I did this before. So it's going to be 1/4 pi or pi divided by 4 for the labels. So that means when I go to do this, my first label is going to be pi over 4. And then my second label will be pi over 2. And then for this one, instead of graphing all positive values, in order for me to get this between the vertical asymptotes, I'm going to have to graph some negatives. So before I continue this, let's just figure out what these values would be. So my first value when at pi over 4, so what is tangent of pi over 4 is what we're really asking here. So think back to the previous unit. Pi over 4 would be in the first quadrant. Now I'm not at one of the quadrantal angles. I'm at a triangle here, so pi over 4. This is equivalent to a 45, 45, 90 degree 45, 45, 90 degree triangle. So this means my ratio here, I have 1, 1, and then this is going to be root 2. They're all positive values. So that means tangent of pi over 4 is going to be opposite over adjacent, 1 over 1, which is just going to be 1. And then when I look at tangent of pi over 2, well, for this one, I can use my unit circle from up above. So I have my x and y values. So remember that tangent is y divided by x. So it's going to be 1 divided by 0 when I'm using that point. So this is going to be undefined. And then that tells me that there's a vertical asymptote there. So when I go ahead and draw this, if I want to draw between two vertical asymptotes, this also tells me that tan of negative pi over 2, so basically if you imagine up here, if we went to the left pi over 2 instead, it would be negative 1 divided by 0. Well, that means I'm also undefined, so that tells me my other vertical asymptote is at negative pi over 2. So I'm going to draw this graph between those. So when I do this, let's go by 2's here, I guess, just to make sure we can fit everything. So this is going to be pi over 4. This value is going to be pi over 2. This is going to be negative pi over 4. And then negative pi over 2. So the only other value I need to find here is negative pi over 4, or for tangent of negative pi over 4. So for that one, I need to, again, consider my triangle here. So this is going to be negative pi over 4. So this means it's 1 and negative 1 root 2. So tangent of negative pi over 4 is opposite over adjacent, so negative 1 over 1, so negative 1. So now when I go to plot these 4 points, this is going to allow me to get the tangent graph that's between the two vertical asymptotes. So at my vertical asymptotes are at pi over 2 and negative pi over 2. This is where my vertical asymptotes are. I'm going to go ahead and draw just a dotted line through there to represent the vertical asymptotes. I'm going to just label this. So vertical asymptote x equals pi over 2. And then for my in-between points here, so at pi over 4, I'm going to have a value of 1. So let's go ahead and just call every 2 boxes 1 here, negative 1. So this is going to be pi over 4, my value is 1. And at negative pi over 4, I'm at negative 1. And then let's also look at 0. So what's happening at 0? Well, tan of 0, we can look at right from our unit circle. So at 0, we're looking at 0 divided by 1. So that gives me 0. So this graph is going to look something like this, where it's going to kind of curve and then it's going to come down and it's going to get really close to those asymptotes but not actually touch it. So there's my continuous function, because really I can draw this curve without picking up my pen or pencil. So that is one way to graph tangent. It's continuous. It's between those two vertical asymptotes. In this picture, my domain for the one cycle is going to be negative pi over 2 to pi over 2. And the range for this, notice that I have arrows on the end. So the range is actually going to be all real numbers. So then the next part is, well, how could I graph this so it's a discontinuous or with just one vertical asymptote? So method 2 is going to be to graph as a discontinuous function. So that means it's going to have one vertical asymptote. So this would be what I probably should have started with this one, because I feel like this is what naturally you would start to do when you're graphing based on how we've done the sine and cosine curves, where if I go right into it, okay, I think about my labels, and since the period's pi, the labels are pi over 4, so the first one is going to be 1 times pi over 4, which is pi over 4, 2 times pi over 4, which is pi over 2. Then we have 3 times pi over 4, which is 3 pi over 4. And then for the last one, we have 4 times pi over 4, which is pi. So for this one, when I go to do my labels, it makes sense with what you've seen, or I should say it follows what you've seen. It's the same pattern, where I'm just doing the positive side. But what's going to happen is the graph is going to look very different, because the graph, you're only going to see one vertical asymptote. So let's go ahead and think about, well, how do I get these values now? So for pi over 4, well, we can just use what we did up here. So for tan of pi over 4, the y value is just 1. For tan of pi over 2, we're going to have a vertical asymptote because it's undefined. So I can go ahead and draw my vertical asymptote. And then for tan of 3 pi over 4, well, that one I'm going to have to draw. So think about when we're doing 3 pi over 4, Well, if this is, so going back again to the previous unit, this is 0, this is pi, this would be 2 pi. If we make these all have a denominator of 4, this would have to be 4 pi over 4 to be equal, and this would be 8 pi over 4. So we would know that 3 pi over 4 ends up in quadrant 2. So this angle would be 3 pi over 4. So then this means that this angle, this reference angle is pi over 4. So we have negative 1 and 1 and then root 2. So tangent of 3 pi over 4 would be opposite over adjacent, 1 over negative 1, which is negative 1. So that would be down here. And then it would be helpful to have values graphed for 0 and pi as well. So we know that tan of 0 we already have is 0. Oops, let me actually graph these all in the same color here. And then tangent of pi we haven't found yet, but tangent of pi we can use our unit circle from up above. So that's going to be 0 divided by negative 1. So that will be 0. So now you can see this graph. Basically what's going to happen is on the left-hand side here, this is going to be kind of that section. It's this section right here. So it's going to go up and get closer to the asymptote kind of with a curve. It's hard to draw that in this graph here. And then on this other side, we're going to be getting closer to the asymptote. So something like this, where it's coming and it's getting closer to that curve, and it's curved, it's getting closer to that asymptote. So the ends here go towards the asymptote. So this is discontinuous because, again, there's a break in the graph. It still is one cycle. It just looks very different. So it's good for you to see both, just so you're aware that both exist. And it doesn't really matter how you graph it as long as you graph one full cycle, or as long as you do what the directions say. Let's just at the bottom here, let's write the domain of this one. So the domain is going to be 0 with a hard bracket including 0, and then a soft bracket to pi over 2. And then it's going to pick back up at pi over 2 with a soft bracket, and then go up to pi with a hard bracket. And then for my range here, it'll be all real numbers again because there's arrows on there. So that is tangent. So the values will be the same, but you can do all this extra work on the side to figure out the values if you need to. But again, I think when we did like the sine and cosine, you figure out how to get the values once, and then you just use that pattern. You just remember it. But if we look at the next page, the next thing I want to do is look at the reciprocal function. So the first one here is the reciprocal of tangent, which is cotangent. So what's going to happen is if we think about, first of all, the period is going to be pi. When I go to do my labels, I'm going to think about my labels as, okay, well, it's the period divided by 4. So again, my labels, I'm going to just do the positive labels. So meaning I'm going to start at 0 and go up to pi, just like the exact same values we did on the previous page. So let's go ahead and just draw that. I'm not going to list them just for the sake of time here. And it's going to be exactly the same as what we did previously. So pi over 4, pi over 2, 3 pi over 4, and pi. And then I'm going to go up to 1 and then down to negative 1. And now what I need to do is come up with those values. So cotangent of 0, then we're going to find cotangent of pi over 4, cotangent of pi over 2, cotangent of 3 pi over 4, and cotangent of pi. So for these, think about your reciprocals. So think back to the previous page. So if I'm looking at cotangent of 0, well, if tangent of 0 was 0, cotan of 0 would have to be undefined because it would have to be 1 divided by 0. It would be the reciprocal of this. So when I look at cotan of 0, that's just going to be undefined. I could also use my unit circle to figure that out. Cotan of pi over 4, well, if I look back, I can use my same triangles here. So pi over 4 just means now instead of doing opposite over adjacent, it's adjacent over opposite. So 1 over 1, it's still going to be 1. Cotan of pi over 2, well, look at your unit circle. So pi over 2, this means I'm doing x over y, so 0 divided by 1 is 0. Cotan of 3 pi over 4 is going to be the reciprocal of tangent at that point. So I can look right here if I'd like. My 3 pi over 4 is just going to be negative 1 over 1. So that's going to be negative 1. And then cotan of pi has to be undefined as well because tangent of pi was 0. So notice the biggest characteristics or the biggest differences between cotan and tan, where tangent is 0, cotan is undefined, and then vice versa. So where cotan is undefined, that's where tangent is 0. Where cotan is equal to 0, that's where tangent is undefined because it's the reciprocal. So where one is 0, the other one's 1 over 0. So that's the easiest way to tell them apart. And honestly, that's how I would remember the differences between them. So when I go to graph these, cotan is undefined at 0. So maybe you even remember that. Cotan is undefined at 0. There's a vertical asymptote at 0 versus tangent is equal to 0 there. That might be the easiest way to tell them apart because they will look very similar. So there's my first vertical asymptote. Pi over 4 is going to have a y value of 1. Pi over 2 is 0. 3 pi over 4 is negative 1. And then we're at undefined again. So we have another vertical asymptote at pi. So again, the ends of these graphs always go towards the vertical asymptote. So something like this. So it kind of curves. Kind of reminds me of a cubic function almost, these little pieces here. So it's supposed to be a little bit more curved than this, but I feel like my scale here, I'm having a hard time making it look as curved as possible. Just remember that those ends are going to go as close to possible to those asymptotes. And also, I didn't say this when we were graphing tangent, but keep in mind that this graph is cyclic, so meaning the pattern repeats. So one full period is pi, this one full unique piece is pi, but if I were to graph more, it's just going to be the same pattern over and over with the vertical asymptotes kind of separating those sections. So that's why the period is pi, because it only takes pi radians to get one unique piece. So the domain for this graph is going to be 0 to pi. Notice I have round brackets or soft brackets because I have asymptotes at 0 and pi, so I'm not including those. And then the domain or the range is going to be all real numbers. So now that's tangent and cotangent. So period pi, vertical asymptotes, they look a little bit different. The last two we're going to look at are secant and cosecant. And for these, I like these a little bit better because you're just graphing sine and cosine, and then we're going to graph the reciprocals. So remember, now we're back to a period of 2 pi. So the pattern here is 2 pi. So let's go ahead and fill that in. And for cosecant, my helper function is going to be sine because cosecant is the reciprocal of sine. So that means when I graph this, business as usual. So the amplitude is 1, the period is 2 pi. My labels are going to go up by pi over 2. Or let me actually show you how I got that. 2 pi divided by 4, so that means pi over 2. So this is just going to be our standard looking graph. I'm going to go up. I'm going to graph just the positive version of this because that's what we're used to seeing. So pi over 2, these are going to take me around the unit circle. So pi over 2, pi, 3 pi over 2, and then back to 2 pi. Again, I can list those out if I need to. And then this is going to be up at 1, down at negative 1, And I'm going to go ahead and graph sine. So sine starts at 0, goes up 1, back to 0, down to -1, back to 0. I'm going to graph this dotted because this is my helper. This is not the answer to the question. This is not the graph of cosecant. Instead, that's just my helper. So now in order to graph cosecant, so for cosecant, what we're going to do is we're going to graph all the reciprocals of these y values. So the x values will stay the same, but the y values, you're going to graph the reciprocals. So graph reciprocal of each y value. So what that means is if I look at 0, so when I have 0, well, the reciprocal of 0 would be 1 over 0, which is undefined. So what that means is at this point, I'm now going to have a vertical asymptote. So I have a vertical asymptote at x equals 0. And now I look at this next y value. Well, the next y value is 1, so the reciprocal of 1 over 1, or the reciprocal of 1 is 1 over 1. That's just going to equal 1, so this point is going to stay 1. Then I'm going to have pi at the x value of pi radians. What's the y value? Well, it's 0, so again, it's going to be undefined. So that, again, tells me vertical asymptote. So I have vertical asymptotes here. So vertical asymptote is x equals pi. And then at 3 pi, I have -1. So the reciprocal of -1 is going to be 1 over -1, so -1. And then the last one here is at 2 pi, the reciprocal of 0 is 1 over 0 is undefined. So that tells me another vertical asymptote. So now I have these 3 vertical asymptotes. And to actually finish this, because we don't really have enough points plotted here to know what to do, what's going to happen is the reciprocal of all of these other points end up going upwards here. So what's going to happen is you're going to basically, it's almost going to kind of look like a reflection in a way. So what's going to happen, and you could actually, find these values and do that, but what's going to always happen is just imagine these values are going upward, approaching the asymptotes. So here, if I kind of flip this shape, it's going to end up looking like this, an upside down U, and it's going to get closer to those asymptotes. So that graph in pink is actually my cosecant graph. So I'm going to just write y equals cosecant of x. And then for the sine curve, I'm going to really small label that really small just because I do have it graphed, but definitely do that first graph dotted because it's not really part of your answer. So there's cosecant. So the easiest way to think about cosecant is it's the reciprocal of sine. So start with sine and then go from there. The last one we're going to look at here is secant. So secant is the reciprocal of cosine. So that means my helper is going to be cosine. So we're going to start off with cosine. It's going to be the same as what we've been doing. So amplitude is 1, period is going to be 2 pi. The labels will be just like before, 2 pi divided by 4, so pi over 2. The period on this is going to be 2 pi, just like cosine, just like sine, just like cosecant. And then we can go ahead and graph it. So we have our 4 intervals here. Let's go ahead and write those. So we have pi over 2, pi, 3 pi over 2, and 2 pi. We're going to go up to 1, down to -1. Cosine starts up at 1, then goes down to 0, down to -1, back to 0, back up to 1. Again, draw this dotted because this is your helper. I'm going to label it really small. And then when we go to do our reciprocal, remember so for y equals secant, you want to graph the reciprocal of each y value. So what I'm doing here is exactly what I did in the previous one. When I'm at 1, or when the y value is 1, I'm thinking about the reciprocal would be 1 over 1, so it's going to have a value of 1. So that means I'm going to plot that point. Then when I'm at 0, well, that means the reciprocal of 0 is 1 over 0, so now I'm at undefined, which means I have a vertical asymptote. So you don't really have to know the values for secant, you just have to be able to find the reciprocals of the cosine values. That's all it is. That's what secant is. So that's the nice thing about secant and cosecant. So my vertical asymptote would be pi over 2. And then following this same pattern, sorry, the screen keeps popping up like crazy. Following the same pattern, my reciprocal of 0 when I'm at 3 pi over 2 is just going to be undefined. So I know there's another vertical asymptote there. The reciprocal of -1 is going to be -1. The reciprocal of 1 is going to be +1. So my graph, remember, we want our ends to approach those vertical asymptotes. We also know that this U shape here, we're going to kind of flip it. This U shape here is going to get flipped. We're approaching the vertical asymptote. Same thing here. And that would be one full period of secant because that's a length of 2 pi. After this, the pattern would just repeat. Now, again, just like tangent and cotangent, these graphs can look different depending on where you draw your vertical asymptotes. So it is important to look at the values. Look for sine or look for cosine to see which function do you have the reciprocal of. That would be my suggestion for you when you finish these up. So let me just go ahead and label this. And then what I'd like you to do is finish up the remaining problems and then check your answers. And that shall do it.